Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories.
Vera Rubin, the woman who unveiled the universe's hidden secrets. Do you think you know the universe? Well, think again. Ever wondered why the outer edges of galaxies spin so fast? Is it dark matter? Or is it something more mysterious, one of astronomy's best-kept secrets? Yes, you heard that right, dark matter. It sounds like something straight out of a sci-fi novel, right? Like those cosmic ghosts you see in movies? But, here's the twist, it was a groundbreaking female astronomer, Vera Rubin, who forced us to rethink everything we thought we knew about the universe. In the early 1970s, Rubin and her colleague, Catherine Freeman, made an observation that would forever change our understanding of galaxies. They were studying the rotation curves of galaxies using spectroscopy when they noticed something bizarre. Far from the center of galaxies, the stars didn't slow down as expected. In fact, they kept speeding along at high velocities, defying the laws of physics as we knew them. It was as if an invisible force was pushing them to spin faster and faster. And that, my friends, was the first hint of something we couldn't see but could only feel: dark matter. But why didn't anyone figure this out sooner? Well, dark matter is like a cosmic ninja. It doesn't glow, doesn't interact with light, and you can't see it with the naked eye. It doesn't even react to electromagnetic forces. It's a mystery that only shows up through its gravitational pull on visible matter. Imagine standing in a pitch-black room, feeling something move around you, but not being able to see it. That's dark matter for you. Now, let's rewind a bit. Who was Vera Rubin, and how did she stumble upon this cosmic enigma? She wasn't born into a family of scientists. In fact, her parents weren't academics at all. Born in Washington, D.C. on July 23, 1928, her dad was a lumber dealer, and her mom was a homemaker. Despite this, they encouraged her curiosity and supported her passion for learning. At a time when women weren't exactly welcomed in the sciences, her parents told her, "You can do anything you set your mind to." That support became one of the driving forces of her life. But breaking into the world of science, especially physics and astronomy, was no walk in the park for a woman back then. In the 1950s, she enrolled at George Washington University, where she was one of the few women in the physics department. The journey wasn't easy, but Vera was tough. In 1965, she earned her master's degree and began diving deep into the field of astronomy. At first, her research didn't have much to do with dark matter. It was more focused on analyzing the light spectra of galaxies. But as she measured rotation curves of different galaxies, Vera began to see the same strange pattern over and over again. The stars at the edges of galaxies weren't behaving as they should. And that's when the dark matter theory was born. But of course, no groundbreaking discovery comes without skepticism. When Rubin first proposed that dark matter might be the cause of the galaxy's strange rotations, many scientists were doubtful. After all, how could you believe in something you couldn't even see? Most astronomers at the time suggested that other gravitational forces might explain the phenomenon. However, as more and more evidence poured in, Vera's idea started to gain traction. By the late 1970s, as her work continued, more and more astronomers realized that her theory made perfect sense. In 1974, Rubin and Freeman published their paper showing how dark matter could explain the galaxy rotation problem. Her findings sparked a new wave of research into the nature of dark matter and its role in the universe's structure. But Vera's legacy extends far beyond the stars. Her work didn't just change astronomy, it had a ripple effect across physics and cosmology, inspiring scientists to reconsider the entire structure of the universe. She showed us that dark matter isn't just a hypothesis, it's a crucial piece of the cosmic puzzle, influencing how galaxies form, how they move, and how the universe itself behaves. So, what exactly is dark matter? Well, scientists still can't observe it directly, but thanks to Vera's research, we know it makes up about 27% of the universe's total mass. That's right, most of the universe is hidden from our view. Dark matter doesn't emit light, it doesn't interact with normal matter, but it still shapes the cosmos through gravity. As of today, experiments like the Large Hadron Collider, LHC, are helping scientists search for clues. But despite all the technological advances, we're still a long way from truly understanding what dark matter is. The mystery persists, but thanks to Vera Rubin, we took that first critical step toward unraveling it. Vera wasn't just a scientific pioneer. She was also a trailblazer for women in science, breaking barriers and inspiring future generations to chase their dreams, no matter how impossible they might seem. Her story isn't just one of astronomical discovery, it's a testament to perseverance, breaking norms, and paving the way for others to follow. Vera Rubin didn't just help us look up at the stars. She taught us that even the things we can't see can change the course of history. Vera Rubin was born on July 23, 1928, in Washington, D.C., to a regular family. Her father, Sam Rubin, was a lumber dealer, and her mother, Belle, was a homemaker. Though they weren't wealthy, they gave her the greatest gift: unconditional support. Vera's dad didn't see science as a man's world. He encouraged her to chase her dreams and explore the mysteries of the universe. Back in those days, many families didn't support girls pursuing science. They believed girls were meant for housework and taking care of the home. But Vera's father? He told her, "Go ahead, chase those stars." And that's how it all started, through an old, battered telescope. Imagine a young girl standing outside, peering at the night sky through a telescope that was always in need of repair. The equipment wasn't fancy, but her dad would smile and say, "That's your star tool." This quirky, hands-on support became the driving force of her life. Vera wasn't interested in just the ordinary world around her. She looked up at the sky and wondered what lay beyond it. In the 1950s, Vera attended George Washington University, choosing physics to fuel her passion for astronomy. And let's be real, in the 1950s, women in science? It wasn't exactly common. Women weren't exactly flooding the halls of universities back then, especially in fields like physics and astronomy. But Vera, she wasn't backing down. In fact, she became one of the few women in the astronomy world, making her mark in what was a very male-dominated field. There's a fun story from one of her lectures. One day, a professor stood at the front of the class and said, "The stars are so far away, no one can ever really touch them." Vera stood up, and with a spark in her eye, she said, "I believe that one day, with enough effort, we'll know everything about them." Talk about idealism. And you know what? She wasn't just talking. She made it happen. In 1954, Vera graduated and began her graduate studies at George Washington University, diving deep into astronomy, particularly spectroscopy. This is where she met her mentor, Joseph Hopkins, who saw her potential right away. He told her, "You don't just love astronomy, you can see things others can't." Little did he know, this comment would become her motto as she went on to make a groundbreaking discovery: dark matter. So, from a simple telescope in her backyard to uncovering one of the universe's greatest secrets, Vera Rubin showed us all that sometimes, a little support and a lot of curiosity can change the world. As the saying goes, shoot for the moon, even if you miss, you'll land among the stars. And Vera, she shot straight for the stars. In 1958, Vera Rubin officially entered the world of astronomy with a bold goal: to challenge a theory that had been accepted as fact for centuries: the rotation speeds of galaxies. According to classic gravitational theory, the farther you get from a galaxy's center, the slower the stars should spin. This made sense, right? After all, gravity weakens with distance, so stars at the edges of galaxies should be moving more slowly. But Rubin's findings were a game changer. She started analyzing rotation curves of galaxies and noticed something odd. Far from slowing down, the stars at the edges were spinning just as fast, if not faster. In some galaxies, the outer stars were spinning in perfect parallel with the inner stars, defying all expectations. This didn't just surprise Rubin, it completely puzzled her. You can imagine the reaction from astronomers at the time. But instead of throwing in the towel, Rubin dug deeper into her data. She spent hours checking and rechecking her observations, determined that this wasn't some mistake or fluke. She realized that something unseen, something we couldn't directly observe, might be influencing the galaxies. She even tried a quirky experiment to help understand what she was seeing. She filled a bottle with ice water, trying to simulate the galaxy's rotation curve. She spun the bottle around, expecting the water to slow down at the edges. But it didn't, just like the galaxies. The water kept spinning at the same speed, just like those outer stars. While this experiment didn't have much scientific value, it helped Rubin grasp the core of the issue. If galaxies' outer stars kept spinning at high speeds, it meant something else was pulling on them, something invisible. That, she realized, was dark matter. By 1959, Rubin had fully embraced spectroscopy to dig deeper. She used spectral data, measuring how the light from stars changed, to calculate their speeds. The results were shocking. Stars at the furthest edges of galaxies didn't slow down as they should. Instead, they were spinning just as fast as the stars near the center. This wasn't just a violation of Newton's laws, it was beyond even Einstein's general relativity. And that's when Rubin made a bold hypothesis: maybe the universe contains something invisible, something we couldn't detect directly, dark matter. This was a challenge to the core of physics at the time, and it caused quite a stir in the scientific community. Rubin faced her fair share of skepticism. Many scientists doubted her data, and some felt her theory was too radical to be true. At one point, during a scientific conference, Rubin was confronted with harsh criticism. She responded firmly, saying, "If we only accept the theories we already know, we'll never uncover the mysteries of the universe." Her conviction made people pause and reconsider her findings. Slowly but surely, other scientists started to take her idea seriously, and the concept of dark matter began to take root in the scientific community. As the saying goes, don't judge a book by its cover. And in Rubin's case, don't judge a galaxy by its outer edges. What seemed like a mistake was actually a revelation, one that changed how we understand the universe. In the early 1960s, Vera Rubin introduced a bold and groundbreaking theory: dark matter. Her hypothesis was simple but radical. If galaxies' rotation curves couldn't be explained by known matter, perhaps there was an invisible substance, dark matter, affecting them. At the time, this idea was nothing short of revolutionary, and the scientific community wasn't exactly on board. One day, at a conference, Vera confidently shared her findings, saying, "I believe the anomaly in galaxy rotation curves might be due to an invisible substance, dark matter." As she spoke, one colleague stood up, half laughing, and said, "You really think there's invisible matter in the universe? Well, I guess I can tell you there are invisible aliens too." The room erupted in laughter, and the atmosphere turned awkward. But Vera, undeterred, simply smiled and responded, "Maybe one day, we'll find them." Her calmness and humor in the face of such mockery only strengthened her resolve. Despite the ridicule, Vera didn't back down. In 1965, she teamed up with Catherine Freeman and published a groundbreaking paper. In it, they stated that the galaxy rotation curves couldn't be explained by known matter and that dark matter was the only plausible explanation. The paper was revolutionary, but it didn't receive widespread support. Many scientists were still skeptical, dismissing her theory as too speculative. Some even joked, "Looks like we'll have to add an entire chapter on this ghostly phantom dark matter in the next edition of astronomy textbooks." Dark matter was seen as an almost fictional concept, a ghost with no solid evidence. It must have felt like Vera was the heroine in a sci-fi novel, battling invisible forces with nothing but her theory. By the late 1960s, Vera's work was gaining some recognition, but she still faced strong academic resistance. Many physicists and astronomers doubted the existence of dark matter and questioned whether it could ever be validated. At one point, a famous physicist directly challenged her at a conference, "How do you explain such a small amount of matter creating such a huge gravitational effect? That's impossible." Without missing a beat, Vera replied, "It's like an invisible giant in the universe, never seen, but its giant steps shake the entire world." Her quick wit not only diffused the tension in the room, but it also vividly captured the essence of dark matter. The image of the invisible giant stuck with the audience, helping them understand that while we can't see dark matter, it's clearly influencing the universe's structure and evolution. Even though direct evidence for dark matter was still lacking, Vera's metaphor helped many begin to grasp its potential role. Her humor and wisdom turned a complex scientific idea into something relatable, something people could begin to wrap their minds around. Of course, Vera's theory still needed years of validation and acceptance, especially with the pushback from traditional physics. But it was her determination and curiosity that eventually brought dark matter into mainstream science. She didn't fear the challenge. Instead, she faced it head-on, armed with her sharp mind and a sense of humor that made the impossible seem just a little bit more possible. By the 1970s, Vera Rubin's theory was finally gaining the recognition it deserved. Her dark matter hypothesis, once dismissed as wild speculation, was now supported by a growing body of astronomical observations and experimental data. The mysterious rotation curves of galaxies weren't just a quirky observation from one scientist, they had become a major issue for astronomers around the world. In 1973, Rubin was invited to give a lecture at Harvard University, attracting scholars from both the fields of astronomy and physics. After the talk, a professor stood up, clearly moved, and said, "I thought I knew everything there was to know about the universe, but today I realized it's far more complex than I ever imagined." Rubin couldn't help but chuckle at this. After all, for years she'd been saying the universe was full of mysteries, and she was like an explorer, stumbling through the darkness with nothing but the ghostly matter of dark matter to guide her. In 1974, Rubin doubled down on her work, revisiting the galaxy rotation curves to further confirm the existence of dark matter. Her research had a huge impact on the astronomy community. Not only did she solidify the case for dark matter, but she also inspired a global push for larger-scale astronomical observations and experiments aimed at detecting dark matter particles. Scientists around the world began pouring money and resources into building stronger telescopes and detection equipment, all in hopes of capturing a glimpse of dark matter's shadow. Along the way, Rubin also had a few light-hearted moments. Once, while working on an experiment at home, she suddenly realized she had almost overlooked a key possibility: ghostly matter. She laughed out loud at the thought of ghosts in the universe. "Turns out, the universe really does have ghosts," she joked, poking fun at herself. Her colleagues and students couldn't help but laugh along. But it wasn't just humor, it was a reminder of how Rubin kept her humility and sense of humor, even when faced with groundbreaking discoveries. No matter how mind-blowing her findings, she always stayed grounded and approachable, facing the universe's mysteries with a smile. As they say, laughter is the best medicine, and for Vera Rubin, it wasn't just about solving the universe's biggest puzzles, it was also about enjoying the journey and sharing that joy with others. Dark matter was no longer just Vera Rubin's theory, it had become the focus of astronomers worldwide. Thanks to her relentless efforts and the support of other researchers, more and more evidence began to show that the rotation speeds of galaxies couldn't be explained by visible matter alone. This led scientists to wonder, could there be something we can't directly observe playing a crucial role in all of this? It wasn't just Vera pushing this forward, it was a collective effort, with astronomers across the globe coming together to explore this unseen force. Slowly, but surely, dark matter became a cornerstone of modern astronomy, a mystery we now know is key to understanding the universe. By the 1980s, Vera Rubin's contributions were finally recognized by the global scientific community. She had not only become a key figure in astronomy but also solidified her place as one of the leading pioneers in the study of dark matter. Her work didn't just shape the field of astronomy, it also prompted physicists to reconsider the very structure of the universe itself. The idea that an invisible substance, dark matter, could influence the rotation of galaxies completely changed how we understand the cosmos. You can imagine that all those who once doubted her were now taking a step back. Rubin hadn't just solved one of astronomy's biggest mysteries, she had opened the door for physicists to rethink the very nature of matter. Her discovery forced the scientific community to acknowledge that there's much in the universe we can't see, yet it's still impacting everything we know. At one of her lectures, a young astronomer eagerly asked, "Could I be the next person to discover dark matter?" Vera smiled and replied, "As long as you're as persistent as I was in searching for the answer, you just might be." Her words were simple yet packed with encouragement, as if she were saying, in science, it's persistence and courage that lead the way. It was this down-to-earth wisdom that made her a role model for countless scientists. By the 1990s, dark matter had become a central topic in modern astronomy. More and more astronomers and physicists were diving into research on dark matter, and Vera's name was now synonymous with the phrase mother of dark matter. Her theory had evolved from a mere hypothesis into a well-supported scientific fact. With increasing observations and data, the existence of dark matter had become an indispensable part of both cosmology and particle physics. Thanks to her groundbreaking work, Rubin earned numerous accolades, including the prestigious National Medal of Science. She became an icon in the scientific world. Her name became immortalized in the annals of science, and people said she didn't just break the conventional boundaries of astronomy, she made the entire physics community rethink the boundary between the visible and the invisible. As the old saying goes, the proof is in the pudding. And in Rubin's case, the proof wasn't just in her data, it was in the legacy she left behind, forever changing the way we look at the universe. In 2016, Vera Rubin passed away at the age of 88. Her death left a profound void in the world of astronomy, but it also marked the enduring legacy of her discoveries, which are now deeply embedded in the core of modern astrophysics. Dark matter, once considered the ghost of astronomy, has since become one of the key pieces in understanding the structure of the universe. While she may no longer be here to lead the charge, her theories and insights continue to inspire generations of scientists. Vera Rubin didn't just reshape the landscape of astronomy, she paved the way for future scientists, especially young women in the field. In a time when the scientific community was skeptical of women's roles in research, Rubin broke down barriers with her determination and talent. She didn't just change the world with her discoveries, she became a beacon for female scientists, showing that a passion for knowledge knows no gender. Throughout her life, Rubin was invited to give talks at major scientific conferences, and by the 1980s, dark matter was no longer a fringe theory, it was central to modern astronomy. Her work became widely accepted, and she was seen as a trailblazer who sparked a new wave of interest in dark matter research. More and more women, inspired by her example, took their first steps into the world of scientific research. Her contributions went beyond just research, they were foundational for the modern understanding of cosmology and physics. Rubin's discovery of the unusual rotation curves of galaxies challenged classical physics and led to her groundbreaking concept of dark matter. This was a pivotal moment in science, as it opened up a new lens through which to view the universe's structure. Today, the study of dark matter and dark energy remains at the forefront of research in astronomy and particle physics. Thanks to Rubin, the search for dark matter continues, with scientists around the world still using advanced telescopes and particle detectors to track its elusive presence. Collaborative projects, like those between NASA and the European Space Agency, work tirelessly to unlock the mysteries of this unseen material, all building on Rubin's pioneering work. In 2020, for example, scientists detected potential signs of dark matter in the data collected from galaxies, another step forward in the ongoing quest she ignited. Vera Rubin's impact also lives on through her work with students. She taught at several prestigious institutions in the US, leaving a lasting mark on countless young astronomers. Her students remember her not just as a brilliant scientist, but as someone who made complex concepts approachable and exciting. Her classes were known for sparking curiosity and encouraging a spirit of discovery. Her legacy isn't just in the research she conducted but in the inspiration she provided to future generations. Rubin often said that science isn't a sprint, it's a marathon, and the key isn't speed, but persistence and the courage to keep pushing forward. Her words, "If you search for answers with the same persistence I did, you might just find them," became a motto for many researchers. Rubin's contributions to the field of astronomy are vast, but her impact on the way we approach science is perhaps even greater. As the saying goes, the road to discovery is never easy. Vera Rubin showed us that, no matter the obstacles, perseverance and a willingness to challenge the unknown would ultimately reveal the secrets of the universe. Her name will forever be etched in the annals of scientific history as a symbol of exploration, curiosity, and dedication. Her humor and wisdom remain alive in the memories of those she inspired. She once humorously remarked when accepting an award, "Scientists always say science has no gender, but clearly, we need more women to unveil the mysteries of the universe." That line wasn't just funny, it was a powerful statement, reminding us that science thrives when everyone, regardless of gender, is given the chance to explore. When we look back at Vera Rubin's accomplishments, it's not just her discoveries that awe us, but the way she changed how we see the universe. She showed us that the path to understanding is not about finding shortcuts, it's about relentless effort, resilience, and the courage to keep asking the hard questions. As she herself once said, the mysteries of the universe are always waiting for us to discover.
The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.